All right, y'all. So 8.4. All right, one more to get in real quick, y'all. Let's see. KD. All right, so this section's about zeros. So they called it theorems about zeros. So the first thing we're going to do is we're going to be given zeros, and they want us to come up with the polynomial that would have produced those zeros they're giving us. So this is going to be the steps to finding a polynomial. Given the zeros. Okay, so the steps to finding a polynomial given the zeros. So remember, zeros are the solutions, okay? So we're basically going to be working in reverse of solving an equation. So the first thing we're going to do, since they're giving us the zeros, we're going to write the zeros out as a solution. I'm going to write each zero as a solution. So if they tell me 2 is a 0 and 3 is a 0, I'll have x equals 2, x equals 3, and so on. Now, once I've wrote out each of my zeros as a solution, I'm going to get zeros on each of those equations. So get a 0 on the right side of each equation. So we'll add or subtract the numbers from each side so that the right side has a 0 and the left side will be like x plus a number or x minus a number. So once I've done that, I'm going to take all my equations and write them as a product equal to 0. So write the equations as a product equal to 0. And y'all, basically now, once I've got everything in my parentheses equal to 0, I'm then going to start multiplying until done. So I'm going to multiply until done. Now, here's a little star on this one. The number of zeros I start with will equal the degree of the polynomial when I'm done. So the number of zeros we start with will equal the degree of the polynomial when we are done. So basically, y'all, if they give me 3 zeros, when I'm done, I'll have an x to the third, which will be a degree 3 polynomial. They give me 4 zeros, then I'm going to end up with an x to the fourth polynomial, okay? So the number of zeros will determine my highest exponent when I'm done. All right, y'all. So y'all, the first few steps ain't done. I mean, ain't that bad. The one that's going to be tedious will be that multiplying. So y'all, let's start out with number 1 here. Find a polynomial of degree 3 with real coefficients that has the given zeros. And y'all, the zeros they're giving us are -2, 3, and -6. So here's what I was talking about here with the star. I've got 3 zeros here, a -2, a 3, and a -6. When we are done, our polynomial will have an x to the 3rd term as the highest term. It will be a degree 3 when we're done. So notice, first step, write each zero as a solution. So that's going to be x equals -2, x equals 3, and x equals -6. All right, so I've got my 3 solutions. Now, step 2, get a 0 on the right side of each one of these. So to make this -2 a 0, we're going to add 2 to both sides. So that one's going to give me x plus 2 equals 0. Second one, I got a 3 on the right side. To make that a 0, I'm going to subtract 3 from both sides. And that's going to give me x minus 3 equal to 0. And y'all, finally, I got a -6 on the right side. So I'm going to add a +6 to both sides. And I get x plus 6 equal to 0. So we've completed step 2. We got a 0 on the right side of each of our equations, which means next, we're going to write these equations as a product equal to 0. So I'm going to put x plus 2 in parentheses times x minus 3 in parentheses times x plus 6. So if I got 3 equations equal to 0, when I write them as a product, they're still going to be equal to 0. So y'all, now comes the fun part, because we now get to multiply all this together. So I'm going to multiply these 2 together to start with. So I'm going to, now you could start with the front 2, but when you multiply 2 things like this, you're going to get 3 terms. So I always like to keep the 2 in front and then multiply by the 3 I'm going to get from this. But I'm going to work that on the side. I'm going to do x minus 3 times x plus 6. So let's FOIL that out. And we'll bring down the x plus 2 here. And then whatever we get from FOILing these 2, we'll throw in our second parentheses. So y'all, over here on the side, x times x is x squared. X times 6 is a 6x. -3 times x is a -3x. And then finally, -3 times 6 is a -18. I'm going to come in here and add the like terms in the middle so that I get an x squared plus 3x minus my 18. That will now go into my second parentheses over here. I'll have my x squared plus 3x minus 18. And all of this is still equal to my 0. So we've done one multiplication. Now we're going to multiply the x plus 2 times the x squared plus 3x minus 18. Now, I won't do that on the side since this is the only thing I got left to multiply. So I'm just going to keep it in line here. We're going to multiply all three of the terms in the second parentheses by this x first. So we got the x times x squared will give us the x to the third. The x times 3x will give us a 3x squared. The x times the negative 18 will give us a negative 18x. So y'all, all we did there was distribute the x in the first parentheses. Now to finish this out, we're going to distribute the 2 through the second parentheses. So 2 times x squared is a 2x squared. 2 times 3x is 6x. 2 times negative 18 is a negative 36. And all that, I still got equal to my 0. So y'all, would ask you at this point, can I go further with this? Is there anything I can do to this polynomial?
Yes, and combine the x's, the 18.
Yes, we got these x squareds in here we can add, and what else? We got these x's we can add. So y'all, let's bring down our x to the third. All right, let's see. We got what? 3x squareds and 2x squareds. So that's going to give us what? 5x squareds. The negative 18x and the positive 6 will give us a negative 12x. And then y'all, where's my number? My number will be my negative 36. And that'll be all equal to 0. So y'all, this one has, they'll have the answer blank will be f of x, and they'll have equals x to the third plus blank x squared minus 12x minus 36. So on this one, they'll have an answer blank really similar to mine. And the only thing we got to do to finish this problem in Math Lab is put our x squared term in here, which was a 5. So in Math Lab, you just put your 5 in there and be done. So, and then some of them, they're going to give us more terms that we would fill in. Okay, so that's how they're sort of checking you out on those. But y'all look at that. My polynomial ended up as the x to the third because I had them 3 zeros. And they even told us on this one that we need to end up with a degree 3. Okay. All right, y'all. So before we can do the next one, I'm going to remind y'all about these imaginary numbers. So this is sort of going to be a recall. Now, since we're going to be multiplying imaginary numbers, the main thing you got to remember, if we get an I squared, we're going to replace the I squared with a negative 1 because that's what it equals. And y'all, I'll show you later on the calculator, there's an I on there above the decimal. So if you hit the blue second button and then the decimal, that'll pull the I on the screen. If you square that I on that calculator and hit enter, it's going to give you negative 1, okay? Now, we need to know this because let's play with some conjugate pairs of imaginary numbers. Conjugate pairs are like x plus 2y and x minus 2i. These are what we call conjugate pairs. Notice everything's the same about them except for the operation. One of them will be added and one of them will be subtracted, but everything else matches up. So these are conjugate pairs. And y'all, the big thing about foiling conjugate pairs, when you foil conjugate pairs, all the I terms disappear. So all those imaginary terms will disappear. So let me show you how that works on one. That way, when we start doing the next problem, we'll see how we only end up with numbers that are real and not imaginary. So y'all, let's foil this. X times x is an x squared. X times negative 2i is a negative 2i x. Now from the inside, I got a positive 2i times x. So that's a positive 2i x. And y'all look at the end, a positive 2i times a negative 2i is going to give you a negative 4i squared. So y'all, the first thing I want you to see, what happens in the middle on this? Y'all got a negative 2ix and a positive 2ix.
So I can't.
Cancels out.
Those two are definitely going to cancel. So I'm going to bring down the x squared. The x's in the middle canceled. Now, what are we going to do about this negative 4i squared? Well, we're going to bring down that negative 4. And what do we say we're going to turn the I squared into?
-1.
Negative 1. So bring down that x squared. And y'all notice, all that I squared, which is a negative 1, is going to do to this number is turn it from a negative 4 into a positive 4. But y'all, guess what? Y'all don't see no imaginary numbers in this anymore, do you? So remember, every time we foil these conjugate pairs of imaginary numbers, we're going to end up with real numbers because the I stuff will cancel in the middle, and the I squared we're going to turn into a negative 1 every time, okay? And that's the big thing about conjugate pairs. They always cancel the middles, and they always get rid of the I's. So y'all notice, now that we know that, they want us to write a polynomial function in standard form whose zeros include 4, 7i, and a negative 7i. Now, standard form, they're just talking about descending order from our exponents, okay? Now, let me ask y'all this. I've got 3 zeros. So what will my highest exponent be when I'm done?
X cubed.
There you go. Perfect. All right, y'all. So let's get to that x cubed by setting each of these zeros as equations. And now we want zeros on the right side, so we're going to add and subtract each of these over. So we'll subtract 4 on the first one from both sides. X minus 4 equals 0. Next, I'll subtract 7i. and get x minus 7i is 0. And y'all finally will add 7i and get x plus 7i equal to 0. All right, so we're happy. We've got 3 equations now with a 0 on the right side, which means we can now write this as factors all equal to 0. So we'll put our x minus 4 in parentheses, x minus 7i, x plus 7i, and setting them equal to 0. Now, the first problem I did, I wasn't that picky about what I was multiplying by what. But y'all, what do y'all think is the first thing I would multiply in this situation?
The x and 7i and the x plus 7i.
Perfect, because if we multiply these i's, we're going to get rid of the I stuff, y'all. So you always want to start with those conjugate pairs if they're imaginary. So I'm going to bring down my x minus 4. And then on the side, I'm going to figure out x minus 7i times x plus 7i. All right, y'all, so here we go again. X times x is going to give us x squared. X times a positive 7i is a positive 7i x. Negative 7i times x is a negative 7i x. And y'all, finally, the negative 7i times 7i is a negative 49i squared. So do y'all see that middle again? It's canceling out again, right? So those two things in the middle are going to cancel. So I'm going to bring down that x squared minus 49. And y'all, the I squared we said was turning into a
-1.
-1. Now you're going to notice every time we pull the conjugate pairs of imaginary numbers, it's going to end up as an x squared plus that number. So notice up here, I need to, because you always got unlike signs, but those I squareds are making them negatives into a positive every single time. Now let's bring that x squared plus 49 over here. And y'all, I liked imaginary stuff better than I did what we did a while ago, because now I just got 2 things times 2 things. A while ago, we had 2 things times 3. All right, y'all, we're going to multiply this now. So watch this. X times x squared. There's my x to the 3rd I needed. X times 49 is a 49x. Negative 4 times x squared is a negative 4x squared. Ooh, and I got a big one here. Negative 4 times 49. Ooh, I think that's what, a negative 196. All of that equal to 0. So y'all, would y'all do anything else to that?
No, there's nothing else because there's nothing else that matches.
So nothing looks good, but what's one thing you would do to this whole thing?
Divide? No.
No, we can't do nothing else to the numbers. But there's one thing we got to do when we put this in the answer blank.
Descending order?
Descending order. Because I got the x squared following the x term, right? So basically, these two need to swap out, and we need to put this in descending order so that we get our x to the 3rd minus our 4x squared plus our 49x minus the 196. And at that point, MATLAB's going to be happy with us, okay? Hey, look, y'all was right. I ended up with a 3 on my highest exponent, okay?
Hey, I'm
I have a
sorry.
question.
Say
You-
again.
Okay.
You can go ahead.
Oh, thank you. So is this gonna be laid out like the other one where we have to like half of the answer is gonna be written in and we just have to put in like
Yeah. So
what the
this one,
terms?
so watch this one. This one gave me an f of x equal to x to the third minus blank x squared plus blank x minus blank. So they basically making us put in all the numbers here, it looks like. So the first number I put in behind that first number would be what, a 4 here.
Yep. And then the
And then
49
my 49.
and then the negative 196.
Negative 196. And what's nice, they're giving us the signs. So if you get done and your signs don't match theirs, then somewhere we got to fix that, right? Now, this third one, they don't really give us this. They just give you 4 answers to choose from. Oh, yeah, but before I do the next example, we got some more recalling to do. And this deals with radicals. So the thing you got to remember about radicals, if you multiply a radical times itself, the square root of a times the square root of a is going to give me an a. So let me show you an example. What if these a's were 3? Square root of 3 times square root of 3 would be square root of 9. But the square root of 9 is 3. Okay, so when we multiply radical times itself, we basically get that number under that radical. So y'all watch this. We're going to FOIL, like I did up here with the imaginary stuff. We're going to FOIL conjugate pairs of radicals. So conjugate pairs. Well, what's nice when we multiply conjugate pairs of radicals? The radicals will disappear. Okay, so imaginary numbers, it gets rid of the imaginary stuff. Radicals, it gets rid of those radicals. So y'all, here we go. X times x is x squared. X times a negative square root of 3 is a negative square root of 3 x. Now I got a positive square root of 3 times x. So that's going to give me a positive square root of 3 times x. Notice I'm not putting the x under the radical. Numbers under a radical cannot multiply by numbers outside a radical, okay? So you can't put the 3x under the radical, only the 3. Now, positive square root of 3 times a negative square root of 3 gives me a negative square root of 9. So numbers under radicals can multiply by other numbers under radicals. So I got a 9. So what's happening here? Look at that middle.
Those two cancel.
So that's going to cancel. So I'm going to bring down that x squared minus, well, y'all, what's square root of 3? I mean, I guess I gave that away. Square root of 9 is a 3. So that goes back to that principle. Square root of 3 times square root of 3 in the long run is just a 3, okay? And what's gone? Do you see any radicals?
Mhm.
The radicals are history, okay? So this next example, guess what? It's going to involve radicals, apparently, right? All right, so let me get my next page ready. So I'm going to turn this over to Kernan. All right, let me pull this back up. All righty. So the next example. Find the polynomial of lowest degree. Whose zeros are a square root of 7, a negative square root of 7, and 3. So y'all notice, once again, they're giving me 3 zeros, okay? So we're going to end up with one of them x cubes again. So let's make our equations. X equals square root of 7. X equals a negative square root of 7. And x equals a positive 3. We're going to get zeros on the right side by subtracting and adding. So I'm going to subtract square root of 7 on the first one. And I get x minus a square root of 7 equals 0. In the middle, we'll add square root of 7. And we get x plus square root of 7 equals 0. And y'all, finally, the last one, we'll subtract 3 and get x minus 3 equals 0. All right, so we now have 3 equations that are equal to 0, so we're going to write it as a product equal to 0. X minus square root of 7, and in parentheses, x plus square root of 7, and in parentheses, x minus 3, everybody equal to 0. So y'all, I bet we're going to be picky on this one when we start, right? I got 3 things being multiplied. What 2 are we starting with?
The square roots.
There you go. So I'm going to multiply these 2 together. So I'll just play with that on the side real quick. X minus square root of 7 times x plus square root of 7. All right, y'all, x times x is x squared. X times square root of 7 is a square root of 7x. Negative square root of 7 times x is a negative square root of 7x. And then finally, negative square root of 7 times the positive square root of 7 is a negative square root of 49. But y'all remember, if you've got the fact that the square root of 7 times square root of 7 equals 7, you could put a minus 7 at that point, okay? Instead of a square root of 49. But once again, my middles are going to cancel.
Can you FOIL that one more time, please?
Say again now.
Can you multiply that out one more time, please?
Okay, so x times x, got my x squared.
Yeah.
X times square root of 7 gave me the square root of 7x.
Okay.
Now I'm going to go my inside.
Mhm.
Negative square root of 7 times x gave me my negative square root of 7x.
Okay. And then the 7 is 749.
So that gave me, since they're both under the radical, I can actually multiply them and get that 49.
But then
So
you just said that we could just do a 7 there, and then when we'd be done.
yeah, if you don't put a radical there, you could just put a 7, and then you'd have had x squared minus 7 and been done. Okay. All right, y'all. So the x2 came down, middle's terms canceled, and square root of 49 was 7. Okay. So yeah, that's what you was asking. Katie, at this point, you could have just said, oh, I know that square root of 7 times that square root of 7 would have made that a 7, and then all you would have had to do is cancel the middles and been done that way.
So that's similar to like, I don't know if you remember, but like the last like 2 chapters ago, when I skipped that because when we were canceling like the H's and stuff,
Yeah.
that's essentially what I could do because like I know those 2 terms are going to cancel out anyway.
Yeah, because remember, we had everything in the second parentheses always canceled out with the first parentheses on those ones and all that fun
Yeah.
stuff. Mm-hmm.
So since those ones, they'll always be opposite of each other in the middle.
Yeah.
So
That's what
angles will always be
that is the
changing.
property of conjugate pairs.
Yep.
Even if these were numbers, the middle two terms are going to cancel out 100%.
Okay.
All right, y'all. So these two things gave me x squared minus 7 times my x minus 3 at the back. All that's going to be equal to my 0. So now 2 things times 2 things. Once again, we're going to multiply. All right, y'all. X squared times the x is going to give me my x to the third. X squared times the negative 3 will give us a negative 3 x squared. Now I'm going to distribute the 7. Negative 7 times x is a negative 7x. And then finally, that negative 7 times negative 3 is a positive 21.
Is equal to 0.
Yep. Now, MATLAB don't make you put the equal to 0. They're just going to have you pick one of the, on this one, they got an A, B, C, D answer. And you just want the one that matches what we got. And y'all look at that. It's already in descending order. So we're good to go on that one. Righty, y'all. So find a polynomial degree 3. With zeros of. So guess what? I've hit you with imaginary numbers, real numbers, radicals. So what's left? Guess what?
Fractions.
Fractions. That's a negative 1/5. So a negative 1/5, 0, and 2. So I'm going to set up my 3 equations. X equals a negative 1/5. X equals 0. And x equals 2. Now, what's nice, when your 0 is a 0, you don't have to do nothing to that. It's already got a 0 on the right side, okay? So I just got to fix the 2 with the negative 1/5 and the 2. So the first one, I'm going to come in and add 1/5 to both sides. So I get x plus 1/5 equals 0. Like I said, I can't do nothing to that one. But the third one, I'm going to subtract 2 from both sides. And I get x minus 2 equal to 0. Now, I'm a little picky when I order these ones out. Anytime I got a single x like this, I'm going to put my single x's in the very front. So I'm going to bring down that x first. And then I'm going to put these binomials, the ones with the 2 terms. So then I'm going to put my x plus 1/5. And then my x minus 2. All of those are now equal to 0. Because it's easier to me to put the single x's out front and start by multiplying these 2 things here. So I'm going to multiply them on the side here. And when I get done, I'll have my x times whatever we get from our foiling. So x plus 1/5 times x minus 2. Now remember, we got those TI-84s to help us with these fractions if we need them. But I'm going to start out with my x times my x. That's going to give us x squared. X times negative 2 is a negative 2x. Now we get to distribute that fraction, y'all. 1/5 times x is a positive 1/5 x. And then 1/5 times a negative 2 is a negative. Now remember, That's like a 1/5 times a -2/1. Okay. So that you
-2/5.
multiply the top and you get -2. And then 5 times 1 is 5 on the bottom. Oh, y'all, look at these like terms right here. We got to figure out what a -2 and a 1/5 equals. So I'm going to bring down my x squared. And y'all, guess what? We got a calculator to do that. If you don't want to find common denominators and all that, go to your calculator and punch in -2 plus 1/5, which is 1 divided by 5. When I hit enter, I'm going to get -1.8. But remember, we got to have a fraction, not a decimal. So you're going to hit math and enter twice. And we get a -9/5. Now, the other way, if you want to do it, you could have did -2 plus, you could have made 1/5 look like a fraction by hitting alpha y equals and hit enter for ND. And you could have done the 1/5 like this. Now, what's nice, if you put it in like a fraction like that and hit enter, it gives you a fraction answer. So -2 and 1/5 is going to give me what, a -9/5. So I get a -9/5, x in the middle, minus my 2/5 at the end. So let's bring that over here. X squared minus 9/5x minus 2/5, all equal to 0. Now, y'all, the reason I put this x out front or my single x's, because all I got to do now is distribute that x through these parentheses. So x times x squared is x to the third. X times a -9/5 x is a -9/5 x squared. So notice I'm just adding one x to everybody. And x times -2/5 is a -2/5 x. And technically that's all equal to 0. But y'all, what MathLab is going to want is just our function, okay? So remember, on this one, put the single x out front, FOIL the other stuff first, and then distribute that single x. All right, y'all, so let's see. One more of these where you got to FOIL, and then we'll get into something else for a little bit, okay? Now, this next one is a little trickier. Find a polynomial degree 4. With -4 of 0 of multiplicity 3 and 0 of 0 of multiplicity 1. So y'all, we got to come up with a degree 4 out of this. So what does this mean? -4 of 0 of multiplicity 3.
Where are my shoes?
Say again?
Where are my shoes?
I think that was someone's kid.
Yeah,
So
yeah.
the multiplicity would be the term of the x.
Well, yeah, when we're done, these multiplicities, remember, tell me how many times a 0 occurs. So if I got -4 of 0 of multiplicity 3, that means I got x equals -4, x equals -4, x equals -4 3 times.
Okay. Yeah, because it's gonna be x cubed at the end.
Well, this is degree 4 when we're done.
Oh, okay.
Because remember, I got one more 0, and that's this one. They said 0 is a 0, multiplicity 1. So that means x equals 0 only happens one time. So since this is degree 4, when we're done, we better have an x to the 4th on this one. So that's already got a 0. So let's get the zeros on the right side of all these. And since they're all -4, we're just going to add 4 to all 3 of those and get x plus 4 equals 0 3 times. All right, y'all remember this. Since I got this single x, I'm going to put it in the front when I write this as a product. And then I'll put all these x plus 4s. And now they're all equal to 0. So y'all, 2 ways you can do this one. Since you got 4 terms here, you can multiply them 2 together if you want. And you can multiply these 2 together if you want. That way you can do 2 steps at once since you got so many things being multiplied.
Could you combine those two and just do an x plus 4 squared?
Well, you could, but that's going to go the wrong way.
Okay.
Because since we're trying to come up with a polynomial, we want all the factors written out so that we can actually multiply them. Yeah, x plus 4 squared would just be like rewriting this with exponents, and it wouldn't be really multiplying it out, okay? So on the side, we're going to do x times x plus 4. And we're also going to figure out what x plus 4 times x plus 4 is going to equal. So we're going to multiply these 2 together, and then these 2, see what we get down here in parentheses. Well, this one's not bad. X times x is x squared. X times 4 is 4x. So my first parentheses will be an x squared plus 4. Now let's get the second parentheses by foiling this. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. So let's add our like terms so that we get an x squared plus 8x plus 16. So y'all, that's going in the second parentheses. X squared plus 8x plus 16. All this still equal to 0. So you notice you get to pretty much multiply stuff about 3 times on this one. So now I'm going to multiply all this together. So the x squared, we're going to distribute it first, and then we'll distribute that 4. Now, when you multiply the x squared through here, you're adding 2 x's to everybody in the second parentheses. You ready? X squared times x squared is an x to the 4th. All right, y'all. X squared times 8x. What do we got?
Cubed.
8x cubed. And then the x squared times 16.
16x squared.
All right. Now all we're going to do is multiply all these 3 by that 4. So 4 times x squared.
4x squared.
4 times 8x.
Oh, hold on. I don't know what my brain was doing. Okay, 32x squared. Hold on. Yeah. Okay, you said 4 times 8? Yeah. 32.
Uh-huh. Now we got a big one because you know Arkansas we quit at 12 times 12, so this 4 times 16 might get us.
Oh,
Okay,
That's
that's a
64.
64.
Uh-huh. Alrighty, y'all, and woo, we got a lot of stuff we can add these well, I guess the only thing I can add is the x squareds, right?
Right?
Because nothing else has like terms. So I got an x to the 4th plus my 8x to the 3rd. What do we got here? 16 and 4. That'll be what? 20x squared plus 32x plus 64. And
I have a
so,
question.
uh-huh.
Do you not add the exponents then? Because like for the 16 and 4 it'd be 20, and then you
Oh,
just keep
but
the
here's
x
the-
squared.
Now remember, the only time I'm adding exponents is when y'all was up here multiplying.
Okay.
When y'all did x squared times x squared and got me an x4. When
Mhm.
you're down here at this part and you're adding and subtracting, x squareds added to other x squareds is just a bunch more x squareds.
Okay.
Okay, so we never change exponents when we're adding and subtracting, okay? Now, y'all, Math Lab will have this, f of x equals, and in the blank, we would put the x4, 8x3, the 20x squared, plus the 32x, plus 64. So that we get back to our original polynomial, and they said a degree 4, and look at that, we ended up with a degree 4. All right, so we're gonna change the tune for just a little bit. And we got what we call rules about zeros. And there's mainly two things we're looking at. The first thing, imaginary zeros. Y'all, the thing about imaginary zeros, they always come in conjugate pairs. So they always come in conjugate pairs. So what I mean by that, if negative 3i is a 0, well, y'all, if negative 3i is a 0, then positive 3i is a 0. Okay, so if you got a negative I, then the positive I is at 0. Also, they could write them as as complex numbers, like we did when we was doing the quad formula before. So if you had something like 2 plus 7i, if 2 plus 7i is a 0, then 2 minus 7i is a 0. Notice the only thing that changes sign is the imaginary stuff, because that's the stuff we got from the radicals. And remember, square roots were either plus or minus those numbers. So if it's in this form, real number and imaginary, then the conjugate of the imaginary number makes it also a 0. Now let's look at the radical zeros. Well, y'all guess what? Radical zeros always come in conjugate pairs. So what we mean if square root of 5 is a 0? Well, y'all, what do y'all think? If square root of 5 is a 0, and they always come in conjugate pairs, then what also must be a 0?
the radical?
Negative.
A negative square root of 5. Good job. Now those can also look like two numbers. So if I had something like 3 plus square root of 2, if 3 plus square root of 2 is a 0, then 3 minus square root of 2 is also a 0. Okay, so once again, the number didn't change, only the radical stuff. Okay. So y'all, now that we know this stuff, I'm going to hit you with my next few questions, okay? So let me let y'all write that down real quick. All right, y'all, so let's see. All right, I gotta move back up again. All right, y'all, so check this out. See what y'all think on this. Suppose a polynomial of degree 4 has the given zeros of, all right, so I got a -3, a square root of 3, and a 6/5. Find the other zero. So y'all, if I'm given zeros of -3, square root of 3, and a 6/5, what's the other zero gotta be?
Is the -3 the +3?
Well, I didn't have a rule about regular numbers like that.
Oh, okay.
0.
All right, so y'all think about this. What did we just say about radical zeros?
Congruent pairs. So that would be a negative.
Yeah.
Square root of -3.
Well, how about negative square root of 3?
Oh, well,
So yeah, Dan, keep them negatives on the outside because remember that was the plus or minus stuff in front of the radicals. So that's how we're getting both of those answers.
So
All
is
right.
the zero of the -3 not +3?
Say again.
You see, you have -3, and then you have. Oh, so we don't find all of them.
No, they gave me these 3.
Oh,
They gave us 3, and there's 4 altogether.
got it. Okay.
Since that's a degree 4, they gave me 3 of them. We had to figure out what the other one was. Well, we knew it had to be the negative square root of 3 because those always come in conjugate pairs.
Got it. Okay. Yep. All right.
Mm-hmm. So same thing. Suppose a degree 4 polynomial has zeros of I and 6 minus square root of 11. Find the other zeros.
Is it positive square root of 11?
Say again now. Okay, so that's one number here, 6 minus square root of 11.
Oh, my bad. Okay, is it 6 plus square root of 11?
6 plus square root of 11. Now remember, that's a degree 4, so you need 4 altogether. So we now have 1, 2, and 3. What's the other one?
Negative I?
Negative I. There you go. So imaginaries have conjugates, radicals had conjugates. All right, so y'all on a roll, so let's try one more of those. So another degree 4. So we know we need 4 zeros when we're done. So a degree 4 has zeros of how about 2 plus 2i and 1 plus square root of 5. Find the other zeros. All right, so what's going down?
1 minus square root of 5.
1 minus square root of 5. So that's
Yeah.
3 out of the 4, so one more.
Is it going to be 2 minus 2i?
2 minus 2i. That's it. So that's my 4 zeros, so we're happy now. So guess what? You almost thought we were done foiling, but let's watch this next example. Find a polynomial of lowest degree with negative 4i and 2 as some of its zeros. Alrighty, so remember when we found polynomials, that's where I took the solutions and wrote them as equations. So I know I got x equals negative 4i. I know x equals 2. Oh, so am I missing any?
Are you missing x
X.
equals 4 positive 4i?
X equals positive 4i. If I give you a negative 4i as a zero, then you automatically got to assume that the 4i is also 0 too. Good job. All right, so let's get our zeros on the right side by adding 4i to the first one. I'll subtract 2 in the middle. And then I'll subtract 4i from our last one. All right, yeah. When I put mine together, I'm actually going to put the x minus 4 and x plus 4i sorted together. So let me throw that x minus 2 out front. And then I'm going to put my imaginary stuff together. All equal to my 0. So y'all on the side, I'm going to start with the imaginary stuff and multiply that. Now, y'all, let me show y'all something. Didn't the middle stuff always canceled on these, right? They're conjugate pairs. So we can actually shortcut FOIL these things if they're conjugate pairs. Instead of having to sit and cancel that middle every time. X times X. So you multiply the first X times the first X and get an X squared. And then instead of FOILing this whole thing, we're going to multiply the two last terms together. So the 4i times negative 4i is a negative 16i squared. Y'all, we don't have to FOIL this whole thing because the 4i in the middle and the negative 4ix, they're going to cancel every time. But y'all, I do got to do one more thing to this. We're not done yet because what do we say I squared equaled?
1, negative 1.
So remember, I squared equals negative 1. So this is basically a negative 16 times negative 1, which will give us an x squared plus 16. So yeah, that I squared equals that negative 1 there, okay? All right, y'all, so that gives me an x minus 2 in the front. Remember, the i's got to be gone when you FOIL these conjugate pairs. So the x squared plus 16 goes next. All right, y'all, so FOIL this. X times x squared is a x to the third. X times 16 is a 16x. Negative 2 times x squared is a negative 2x squared. And then finally, negative 2 times 16 is a negative 32. But of course, we've got one more thing to do to that. And that is put this thing in
Descending order.
descending order. So y'all, we got our x to the third. What's next? A minus 2x squared plus our 16x, and then minus 32. And then remember, they'll have f of x equals, and you're just going to put in that part right there into the answer blank, okay? So you notice today is a lot of foiling.
Yeah, and a lot of that side work.
Exactly. Because you're having to foil something before you can actually multiply the other stuff. So, oh yeah. So y'all gonna have fun foiling tonight.
Mm-hmm. We're gonna turn it to some foil.
All righty, y'all. So how about same thing. Find a polynomial of lowest degree. And they're not giving it away by saying lowest degree. That way you don't know how many zeros you're supposed to have. So find me a polynomial of lowest degree with the following as some of its zeros. All righty, so let's see. They're giving me a square root of 5 and a 5i. Which means we're going to have x equals a square root of 5. X equals 5i. So is there any more?
Negative 5i.
X equals negative 5i. Is that all of them?
A negative 5. Radical form negative 5.
So, well, make that negative on the outside.
Yeah.
All righty. So, yeah, we got conjugate pairs of the imaginary and the radicals this time. So, y'all, let's get our zeros. So, start subtracting and adding. So, then I'll subtract 5i on that one. Add 5i to the third one. And then add that square root of 5 on that last one. And y'all, I'm going to definitely put my radical stuff together and my imaginary stuff. So I'm going to start with my x minus square root of 5 times x plus square root of 5. My x minus 5i times my x plus 5i. All of that stuff will be equal to 0. Now, I'm not going to do these on the side because these ones ain't too bad. So I'll just multiply them as I go. So I'm going to multiply this one. And then I'll multiply this one. Now, guess what? Conjugate pairs, conjugate pairs. I'm going to do the shortcut foiling instead of having to write all this out. So my first parentheses, I got an x times x, which is an x squared. A negative times a positive will make this a negative. And then a square root of 5 times square root of 5, remember the last times the last, gives me a square root of 25. But remember, I could have just put what there?
5.
Yep, because remember, square root of 5 times square root of 5, in the long run, that's just going to be a 5. Now, shortcut the second one, it's conjugate pairs. So x times x gives me an x squared. Negative 5i times 5i gives us a negative 25i squared. So our next step, we're going to take care of that square root of 25 and make this an x squared minus 5. Now, what's this negative 25i squared going to turn into?
Is it going to turn to a positive?
It's going to turn
25
into,
I squared? Okay.
well, the I squared is gone because we made that a.
Oh,
Negative.
yes, it has to be a -1. Got it.
So that negative times negative made that a positive.
Okay.
So now we got two things times two things. We're going to multiply again. So they're not having no pity on y'all for foiling tonight, okay? All right, y'all, here we go. X squared times x squared is an x to the 4th. Now, this one I can't shortcut because these aren't conjugate pairs, right? So we're just going to have to foil everything out. X squared times 25 is a 25x squared. Negative 5 times x squared is a negative 5x squared. And then, y'all, the negative 5 times 25, whoo, that's what, a negative 125. So my question is, can I go further?
Yes, because you
The
can.
x
The
squared.
x squares are like terms.
There you go. So we got our x4. What we got? 25 minus 5 will give us 20 x squareds. And then minus our 125. And y'all, Math Lab only wants our polynomial. All right, now we're out of making polynomials. Now we're going to find zeros. Okay. Before we found zeros by using the quad formula, and we even used synthetic division to determine if a number was a zero or not. So now we're going to be given a polynomial and we're going to find all the zeros, okay? So the polynomial has the given zero. They say, find the other zeros. All right, y'all. So the zeros they're giving me is -3. My polynomial is f of x equals x to the 3rd plus 3x squared minus 7x minus 21. So y'all, what we're going to do, we're going to run synthetic division using -3 as my first zero. Now, I got to keep doing synthetic division until I get it down to 3 numbers under the quotient. Because at that point, when you got 3 numbers left, it's going to be quadratic. Now, since this is the x to the 3rd, I've only got to do synthetic division one time, and then my coefficient will be quadratic. If that was the x to the 4, I would have to do it 2 times before I got it down to 3 numbers, okay? So we start with our -3 that they're giving me as my first zero. Now write out your coefficients. Nothing's missing. So we got a 1 for the x 3rd, 3 for the x squared, -7 for the x, and our -21. Then I'm going to draw my bar. Now, let me ask y'all this. If this -3 is a 0 of this polynomial, what had I better get for my remainder?
0.
A 0.
A 0, good job. So if I don't get a 0 here, I know I messed up because they're giving me that one, right? All right, y'all. So y'all remember what I'm going to do? I'm going to take that 1 and
Bring it down.
bring it down.
So I mean -3 over under the 3.
Okay. Add them together.
-6.
0.
Oh, they cancel. Duh.
Oh, yeah, they canceled. There you go. Make that a 0. And then look at that. 0 times -3.
0.
-7 plus 0.
-7.
And look at that. -7 times -3.
+21. So then it's a 0.
And there's my 0 remainder. We got to get a 0 remainder on that. So we knew that because they told us -3 was a 0. But now what we're worried about is these 3 numbers. Remember, it starts 1 degree less. So this is an x squared plus 0x. So I don't have to write that because 0x is gone. So it's going to be at 1x squared minus 7. So y'all, since it's quadratic now, it's got an x squared term as the highest exponent. At that point, I'm going to set that equal to 0 and get my last 2 numbers, okay?
Hey, how'd you get that x squared again?
Because these numbers are the coefficient of the new polynomial, and they always start 1 degree less than the original polynomial. So since the original was the x third, our coefficients start with an x squared term, our x term, and then our number.
Okay, I got you.
And y'all, to solve this, we're just going to what? Add 7 to both sides and do our square root stuff. So that x squared equals a +7. Turn that x squared into an x by taking square roots. So y'all, square root of x squared is x. What's the square root of 7? Well, we can't do that. But what am I going to put in the very front? I'm going to put a plus or minus square root of 7. Remember, when we deal with radicals, they got to come in conjugate pairs, right? So the other zeros are going to be a square root of 7 and a negative square root of 7. We started with an x to the third. They gave me 1 0. I got the other 2 because we had to end up with 3 on that, right? All right, y'all. Watch this. For the polynomial, 1 0 is given. Find the remaining zeros. All right, so the 0 they're giving us, they're saying our polynomial is p of x equals x to the 4th plus 40x squared minus 441. And y'all, they're telling me 7i is a 0. So when we're done, we need a total of 4 zeros. They're giving me 1, so I got to come up with the other 3 on this one, okay? Which means the first number I'm trying to use on my synthetic division is that 7i. So 7i is the first number I'm trying. Now, y'all, be careful on these coefficients you're about to write, because I'm missing the x third term and I'm missing the x term here. So in place of the x3, I'm putting a 0, and in place of the missing x, I'm putting a 0. So I get 1 for the x4, 0x3, 40x squared, 0x, and then my negative 441. You gotta have.
Miss Eugene, that just threw me off a little bit because, okay, literally all I'm seeing is x to the fourth plus 40x squared. So my mind would think 140 and 441. The
Yeah,
zero, where they come from?
but remember, we gotta have everything in descending order. And you don't have an x to the third term here. So you gotta put a. Okay, so let me show you. This is really like, let me show you what this is really like. This is really like an x to the fourth plus 0 x to the third plus 40 x squared plus 0x minus 441. Remember, when you're doing synthetic division, every single exponent has to have a coefficient here. And since I didn't have the x3s, I got to use a 0. Since I didn't have x's, I got to have a 0 there because I need placeholders for those missing degrees, okay?
So the x's are the x cubed and the x is important.
Oh, yeah. Oh, yeah. I need placeholders here, and you're about to see why.
Okay.
Because see, the x4 term, you're going to bring that 1 straight down. Now, what is 1 times 7i? 7i. What is 0 plus 7i? 7i. All right, now, y'all ready? What is 7i times 7i?
49i squared, right?
Okay, but what's that I squared going to do? So right now you got a
Turn it to a
49.
negative one.
Yeah, that's a -1. So all the I squared is going to do is make your 49 into a.
-1. Oh, negative 49.
Yeah, because you're replacing that with a -1. So just remember, when you get a 49i squared, that's like 49 times -1, which gave me a -49 there. All righty. What is a -49 plus 40? Is a -9. All right. -9 times 7i is a -63i. Well, y'all, 0 and -63i give me a -63i. So now watch this. You got a 7i times a -63i. What does that give me when I multiply 7i times -63i? So it's going to be a negative what?
Negative 441. Oh, yeah, negative 400.
I squared, right?
Yeah.
But what's the I squared doing to your -441?
It is making it a positive 441.
There you go. Well, we knew that because guess what? We knew this remainder better be 0, right? Since they gave me the 7i, I knew that remainder better be 0. Now, look at my new polynomial. We started with an x to the 4. That means this is now 1x to the third plus 7i x squared minus 9x minus 63i. That's my new polynomial that I'm going to use for my next synthetic division. So y'all, here's my question. What would be the next number y'all are going to try to find a 0 from? Because I can't do the quadratic formula and stuff because this is still too high of a degree. Remember, I got to get it down to an x squared before I do my quadratic stuff. So what's the next zero y'all going to try?
It can't be negative 63, can it?
No, it's not none of these numbers,
Oh,
but it
Let's
has
try
to
negative
be
7i.
negative 7i. Perfect. Because if they gave you 7i, remember, its conjugate pair better be a zero also. All right, good job. So now let's put our numbers down. We got a 1, 7i, negative 9, and negative 63i. So basically, these numbers under this bar are the numbers you're trying on the next synthetic division. If I'm right, I better get a zero here, okay? So y'all, let's go. Bring that 1 down. 1 times negative 7i is negative 7i. Well, y'all, what happens there?
you know, negative 79 times negative 79.
Well,
Cancel out.
yeah, they cancel out, remember? So add them first and get me a big zero there because those cancel. Now, 0 times negative 7i is a 0. Negative 9 plus 0 is negative 9. Guess what? Negative 9 times negative 7i is a positive 63i. And y'all, that gives me a remainder of 0. So I know that the first of the 3 zeros that I needed to find was a negative 7i. Now remember, this is now the new coefficients, and it's going to be 1 degree less than that x to the third. So that's going to be a 1x squared plus 0x, I don't have to write, minus 9, all this equal to 0. So y'all, I'll solve this like I did a while ago. I'm going to add 9 and then do our square roots, okay? So let's add 9 to both sides. I get x squared equals 9. Next step, take square roots of both sides. So that I get my x equals, we all square root of 9 is going to be what? A plus or minus, I think I heard it.
3.
3, there you go. So that's my other 2 zeros, 3 and negative 3. So here for the other zeros, now we don't put the one they gave me 7i. So we found negative 7i was a 0, 3, and negative 3. So good job, y'all. That was good figuring that out. If they give you imaginary, then you got to do the conjugate on that one, okay? And then once we got them 2 zeros out of the way, it becomes quadratic. And once you're down to 3 numbers, especially if you got a 0 in the middle, do square roots and get them other 2, okay? All right, we're finally down to one more problem. Now this one's the funnest one of them all, because guess what? They're not giving us none of the zeros. So what they want me to do is find the rational zeros. So rational zeros are zeros that aren't radicals or aren't imaginary. And then the other zeros. If there's other zeros, find them. So that's part A. Part B, they want me to factor this into linear factors. And I'll show you what they're talking about that. Factor into linear factors. Now, y'all given me f of x equals x to the third minus 21x plus 20. But guess what? They didn't give me any zeros to start out with. So what I'm going to do to help me find at least one zero, I'm going to graph this in y equals. So I'm going to graph in y equals to find at least 1 0. So y'all, let's go to our calculator and graph this real quick. So let me clear that. I'm going to go to y equals, and I'm going to plug in my x to the third. And then arrow down, and then minus 21x. And then plus 20. And then let's just graph that. I'm looking for this place. Whoops. Let me zoom my calculator back down to regular. I must have had it on one of them problems we did last week. So I'm going to put it on my regular standard. If you do zoom standard.
So did you hit zoom before you hit graph, Mr. Eugene?
Well, I was wanting mine to look. Let me see. Oh, you know what I did? I put a 200 instead of a 20. That's what's messing me up. So let me go fix that. So let me delete that one number there. So where's delete? Right there. Okay, I had a 200 instead of 20. That's why I was sort of freaking out. So when I hit graph, I'm looking for the 3 places it crosses the x-axis. And you don't have to zoom it. You already.
Oh. Okay. Well, what were you talking about with the zoom?
Well, I thought my calculator was out of. I thought it was still sitting on that negative 100 from when we did that stuff last week.
Oh, okay. You're trying to fix it. Okay.
So let's see. Let's see if we can see where this first one over here is crossing. That's -1, -2, -3, -4. Looks like that's crossing at -5. This next one, it looks like it's crossing at 1. And then let's see, 2, 3. And it looks like that last one is crossing at 4. So I can pick any one of them numbers. But y'all, since this only has 3 zeros, when I'm done, that's going to be the 3 zeros, okay? So now watch this. If I hit second table, when I had that -5, what's that y value? It is 0. So that tells me that's a 0. This 1 right here has got a 0. So that tells me 1 is a 0. And then if I go down here to 4, I get a y value of 0. So that tells me 4 is 0. So we know the 3 zeros are going to be what? -5, 1, 4. And the 4. So let's go back.
Okay.
So the first thing they want, so they'll have 3 choices. A, there are only rational zeros. Since all 3 of ours, we could tell when they're crossing the x-axis, they're all rational zeros. So we would come in and put on this one, A, there are only rational zeros. And the zeros are blank. So what did we say we got? We got a -5, a 1,
and a 4.
And a 4. So put them in with their commas. So those were my 3 zeros. Now the second part said factor into linear factors. So the factorization of f of x into linear factors is blank. So what you're doing, you're going to take each of the zeros and put them in parentheses. Now here's the thing. What do we know about zeros and the factors? Well, the factors always have opposite signs than the zeros, right? Well, ago when we was making those equations, if -5 was a 0, we set x equal to -5. But when we made it a factor, we added 5 to both sides so that we got x plus 5 equals 0. So that's what they're doing here. So if x plus 5 is my first factor, what's the one giving me as my next one?
Negative.
Oh,
X equal or X minus.
yep, that has to be x minus 1. And then what's the last one for the 4?
X minus 4.
That's all you're doing. Once you got the zeros, change the sign and write them as factors. So that there is our linear factorization, and we're all done. So y'all, on this one, this will be like number 13 for y'all. Graph it, find where that thing's crossing the x-axis, and they're all going to be rational zeros for that one. And then write them as factors and be done.
I have a question.
I hear you.
What if you don't have one of those calculators?
Oh, so
I guess I just I don't know.
well, you can get one on your phone.
Oh, really?
Look, let me show you what I got an Apple phone. But on my Apple phone, I got a little calculator called Calculator 84. If you download that Calculator 84 app, it looks just like my TI-84. And you can go to Y equals on that. Let me clear that one out. And you can put it in right there. So these phone apps will graph and do everything like my TI-84 handheld, okay?
What is it called?
So let me cancel that. It's called, let me zoom in a little bit. Let me see if I can zoom that in. And then let me try to make that read that better. So right here, it's called Calculate 84.
Oh, okay. Thank you.
So I got that on the iPhone. I don't know what it'll be called in the what are y'all what's the other one it's called? If you don't have an iPhone, you got a
Samsung or Galaxy.
Galaxy, yeah. So they got a different app store, so I don't know what theirs will be called on that one, okay? But I know on the iPhones, it's just any TI-84 app ought to work though. Well, I'm all zoomed in now. All right, y'all. So that is 8.4. So it'll have those 13 questions like we went over tonight. It starts out doing a lot of foiling, and then you get into a little bit of stuff about those zeros. And the main thing to remember on these is that conjugate pair stuff. If you get a square root of 7, negative square root of 7, and you had this 7i, you had to check negative 7i. So those are always going to come in conjugate pairs, okay?
And I just downloaded that app. It's free, by the way.
Oh yeah, that Knife Chat hat is definitely free.
That's crazy.
And it'll do everything I did on my calculator all year long. All right, y'all. So y'all hang on a second. I'm going to make sure I got everybody on this row. All right, I got all of y'all. So let's see. Yeah. So Dan, Hannah, Kira, I got you. Diamond Butler, I got you. Deshaun, I got you. Christina, I got you. All right, y'all, I got to everybody. So I'm going to quit recording this thing so I can get this thing out tonight.